Okay, so welcome to today's class. In today's lesson, we are going to basically focus on ionic bond and that of covalent bonding. So we're going to talk about ionic and that of covalent covalent bonds. So we will cover both ionic and that of covalent bonds. So before drafting into ionic bond and that of covalent bond, you should first understand what is a bond or what ions are. So logically, we can say that a bond is a chemical link between atoms, thing that connects atoms together. Let's say, for instance, you have a gap somewhere and you want to fill that gaps, or maybe you have something of deficiency that you want to like overcome, or we say point A is here and point B is being right here, but there is a gap in between them right here. So right here, if you try to like connect point A to that of point B, maybe using a rope or maybe using something else. So the aspect of it connecting from point A to point B right here, you have definitely created a bond. So chemically, we say that a bond is a chemical link between atoms. So chemical links mostly talks about electrons, right? So chemical links mostly talks about electrons, and we know what electrons are, right? Electrons are species that has mostly a negative charge. Yes. So electrons are species that mostly has or have a negative charge. So if you have connected them together right here, it becomes a bond. So we have now learned about bonds. So what becomes of ion? What because of ion? What is an ion? Well, in chemistry, we can say that an ion is a species that contains either a negative charge or a positive charge. A species could be an element, it could be a compound, right? So let's say for instance we have hydrogen as the number one element on the periodic table. So in this case here, hydrogen has a charge of positive one, making it an ionic compound right here. Because of this, it becomes an ion, right? Excuse me, an ionic element right here, right on. So because of this right here, it becomes an ion. And we say ion are species that contain either a negative charge or a positive charge. So this become an ion of what? Of hydrogen. Okay, so again, we want to look at another one that has a negative charge. Let's say oxygen, right? So oxygen is -2. So it details that the oxidation stage of oxygen, which is letter O, is -2. And this is also serving as an ion, but in different form. This is negative right here, and this is positive. So a positive charge ion is mostly or is called a cation, right? So a positive charge ion is called a cation. So this is the ion right here, and a negative charge ion is called an ion. So I hope you have understood what they are, right? So you also have to understand about superscript and subscript if you are drafting into ionic bonding or chemical bonding. So if you look here also, you have positive here and -2 here. They are above. So if you have like something like H2O and this 2 is being hanging at this, it is called differently. So for this one up here, you refer to it as a superscript. What is a superscript? A superscript is the number above an element or a compound, right? So most of the superscript comes in the front of ion. So for this, if you look here, you see H has 2 pin hanging at this. It tells that there is 2H to what? 1 oxygen in this compound right here. So for subscript, they are mostly hanging, and for superscript, they are up. So I hope you have understood that. And now we can now draft into our main topic that says ionic and covalent bonds. So what are ionic bonds? Yeah, well, ion. It talks about species with either a positive charge or a negative charge. So what is an ionic bond? Well, from the simplest definition, we can say that an ionic bond is the transfer of electrons between metal elements, between metals element and non-metals element. I repeat, we can say that ionic bond is the transfer of electrons between metal element and that of non-metal element. So we have two keywords again that we have introduced. So they are metal and non-metal. So what are metals element? Again, from the simplest definition, we can say that metals elements are elements that want to give away or that want to lose electron. So for metal element, they want to give away or they want to lose electron mostly. And for non-metal, these are elements that mostly want to accept electron or to gain electrons in order to certify or to obey their octet or their duplex rule, right? So you have now understood what ionic bonds are, what metals element are, and what non-metal element are. So we can now move to covalent bond. So what is a covalent bond? So for covalent bond, it mostly occurs between non-metals element. So we can say that covalent bonds is the sharing of electrons between non-metals element, mostly between element that wants to gain electron. For instance, Amos and maybe she is XYZ, she wants to gain electron and I too want to gain electron. So we both become we both become non-metals element because we want to gain. So let's say for instance, talking about non-metal element, mostly we say they want to gain electrons in order to certify or to obey their octet or duplex rule. We said octet or duplex because octet talks about 8 and duplex talks about 2. So it's not always the elements on the periodic table that obey the octet rules only. Some of them do obey the duplex rule, like element like hydrogen. It does that. It obeys or it wants to obey the duplex rule, not the octet rule. Elements like helium, number 2, for this it obeys the duplex rule, not the octet rule. That's why mostly helium, it says that helium is certified because of its duplex rule that it obeys, because it have 2 electrons in the outer shell of helium. So I hope you understood that. So we can now give examples of ionic bond and that of covalent bond. When we are going to give examples of ionic bond and that of covalent bond. So before doing that, we can look at the periodic table. If you look right here, we have element being placed in this position right here. These are the S blocks element, and if you look here, the first one here is the carbon elements, which of course you can find hydrogen there, but it's being placed in the different background, exception to all those ones that are red down here. So we say that element in group 1 have the charge of positive, or we say +1, wherein all elements in group 2 have the charge of positive 2. So there's group 2 right here. So elements in this category have the charge of positive 2. So what does it mean to have a charge of positive 1 or positive 2? It simply tells that element that has a charge of positive, it means that it wants to give away 1 electron or it wants to lose 1 electrons. An element in group 2 that have the charge of +2 or you say positive 2, it tells that those elements in that group wants to give away two electrons in order to satisfy or to obey the octet or duplex rule. So I hope that has been understood, right? So we can naturally get example of ionic bond. And we say ionic bond is the transferring of electrons between mentals element and non-mentals element. So we say right here, both group 1 and group 2 are mentals element exception to hydrogen, right? And if you want to find non-mental element, mostly you come to the P block right here, the P block. So the P block, if you look in group 17 right here, most of them are gases. You see them in red. This natural, you see them in red, and fluorine, chlorine, they are all gases, right? That's why they are being placed in the red right here. So all those one here, you see, they are all non-mental element. And we say, what are non-mental elements? These are elements that wants to gain electrons in order to satisfy or to obey the octet or the duplex rule. Okay, so we can pick an element from group 1 or group 2 and also pick element from group 17, or let me say group 6 right here, or 16, because oxygen is also a non-mental and is being placed in group 6 and it's a gaseous element. Okay, so can we take element like, let's take potassium. We take potassium is K. Potassium is being formed in group 1 of the periodic table. That means that it has a charge of positive, because we say element in group 1 has the charge of positive. They want to give away one electron in order to satisfy or to obey the octet or the duplex rule, right? So if you pick an element in group 1 and you want to have a bond with element in group 17, which are non-mental elements, so we can write this right here. We say plus. Remember, this element wants to give away only one electron. Just one electron in its outer shell, it wants to give away. It wants to lose it to satisfy the octet rule. So if you have to bond potassium to that of, let's say chlorine, which is Cl, since chlorine is in group 17 or group 7 of the periodic table, that means that it wants to accept one electron, or it wants to accept or gain one electron in order to satisfy or to obey the octet rule. Okay, so if you were given such an equation like this, an ionic equation like that, as you can see, this is not the normal equation, this is ionic equation. So it tells you that if we add potassium ion to that of chlorine ion, what it produces. So you understand that this is a mental and this is a non-mental. So definitely this tells you that it's an ionic equation, because the reaction between mental element and what non-mental element. So in this case here, they are going to transfer the electron. So right here, the charge of potassium here is positive. This is the electron right here, and this is negative as well. So if you look right here, this here is positive. So it means that this guy gives this one to chlorine. Chlorine accepts that, and chlorine gives a negative one to potassium, and it also accepts that. But have in mind that the charges are all the same. It's positive and negative. It's like you are saying 1, we is positive 1 here, minus negative 1 is here, minus negative 1. It gives you a 0. It tells that they are going to form a neutral compound. Neutral compound, because if you say positive 1 minus negative 1, it gives you 0. So it tells that K will just be K and Cl will just be Cl. So this becomes a neutral compound, giving you potassium chloride. So it's how this particular compound was being, or is being formed, right? Because it is an ionic compound and it exists between mental and non-mental. Okay, so another example would be, let's say we have picked the same potassium. We maintain that, okay, the concept. You have potassium to have the charge of positive plus. You want to add potassium to that of oxygen. Which group is oxygen in? We say oxygen is a non-mental, it's a gaseous element. So it's in group 16, or we say group 6 right here. So the charge of oxygen is -2 because it's in group 6 and it needs 2 more to make it 8 in order to obey or to satisfy the octet or the duplex rule. So the charge of oxygen is going to be -2 because it needs 2 more to obey the octet rule. What you need is the charge you're going to get right there, being positive or negative. So if we add oxygen to that of potassium ion, the charge of oxygen becomes -2 because it's in group 6 and needs 2 more to make it 8 in order to obey or to satisfy the octet rule. So we adding that, what will it produce? This is an ionic element right here. You see positive here is positive, this one negative is -2. So we say for ionic compound, for ionic structure, they want to transfer electrons between mental and non-mental. They want to transfer electrons between mental and non-mental. There's a mental, there's a non-mental. So they will transfer the electrons. So it means that this K you see here, K this positive to oxygen accept. Then this -2 you see here, all give is to K and K accept. They are transferring the electron. Give me your own, I give you my own. So it will occur right here. So it means that after they have done that, the charges now it become a subscript instead of a superscript. Their charges will become a subscript, not a superscript again, as I told you previously about subscript and superscript. So it means that this plus you see right here, K has given it to O accept. So there's 2 lost from there now. Then O gives it to K accept. So it becomes now, say K is first right there, we write K. What O gives to K is 2, right? Is 2. So right here, we're going to denote a charge like this now, negative charge. We're going to denote this now. So we're going to say that there's 2 you see right here, it becomes a subscript, but since it has been transferred, because excuse me, there's 2 you see right here, it is a superscript, and once it accepts, it becomes a subscript. So it means that this 2 is going to be hanging right here. Then this positive 1, K gives it to O accept. So just be just 1 O. So it will be this. So it becomes potassium oxide. So this becomes potassium oxide. Why are you seeing this? Why are you seeing this? If you see this 2 here, initially that 2 came from oxygen. Initially, this 2 here belongs to oxygen. It tells that if you have to draw the structure of this particular compound, you will get to understand how this was being formulated. Okay, so we can do that to give a proof of it. Okay, so we say potassium is element 19 and oxygen is element 8, right? Can we write or can we draw the structure of them? Okay, so in this case here, we can try to draw the structure of this particular thing right here to fully understand how this compound was being formulated if it cannot be understood from this scenario, right? So we said that number for potassium is 19. 19 is the atomic number of potassium, wherein 8 becomes the atomic number for oxygen. So to draw the structure of them, we can use this periodic table. Like I told you in my previous video that there are 118 elements that are formed within the periodic table, right? So we have something we call 2, we say 2, 8, 8, 18, 18, 32, 32. If you sum them, it gives you 118. This simply tells that the first area of the periodic table contains 2 elements. If you look right here, the first group right here, it has 2 elements here. So here is group 1 right here. It has 2 elements. As you can see, 1. If you go this way straight, it's 1 here is 2. So this 2 is that. And the next area, if you go this way, you have 8. So it's the 8 right here. So the next area, it will be the same 8. It's the 8 right here. Then you continue and come right down here, you get the total of what? 118. So we will use this. We say that the first shell takes only 2 electrons. It cannot take more than 2 electrons because it has two elements within that particular group. It has 2 elements within that particular group, or we say row. Okay, so potassium is element 19, right? If we are to draw the structure of that, I can just erase this area to give more clarity about that. So we say the first shell, we can put potassium right here. So the first shell of potassium, we say it takes 2 electrons. So we have 1 here, we have 2 here. So if we minus 2 from 19, what left? It left with 17, right? So we can draw our next shell. So the next shell, it takes 8 electrons. The next shell takes 8 electrons as maximum because it contains 8 elements within that particular row, as we just shown just now. So this here now, we have 2 here, and potassium is 19. We have consumed 2. We are level 117. This can take maximum of 8. So we can do this right here. We write this 1, 2, 3, 4. We should firstly write the bond single before we can try to make them as a lone pair or to double them, right? So we have 1, 2, 3, 4, 5, 6. And this shell you see here, it takes 8 according to that. So we can now try to double them, giving a lone pair. So we say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we have consumed 10 electrons. How much left to make it 19? We level banana now, right? And the next shell here, it takes 8 electrons also. So we can draw our next shell right here. Draw this shell right here. So this shell also take 8. This 8 right here. Where the single 1, 2, 3, 4. We can double 4, 5, 6, 7, 8. We can now try to check them. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. And potassium is element 19, right? Potassium is element 19. So the next shell is here, it takes 18 electrons. But only level 1 to make it 19 right here. So we draw that shell. We draw that shell right here. We draw that shell, we just write that single electrons. We just write that single electrons right here. If you count all, it gives you a total of 19. So that becomes 19, right? So that is for potassium. It means that potassium prefers to give away 1 electron than to gain 7 to make it what? 8. Do you have that logic? Potassium has 1 electron in this outer shell, in this last shell right here. It prefers to give that 1 electron away. If it does that, then this particular shell gets broken. Then you'll be level 8 to the next shell. Then it obeys the octet rules, not the duplex rule, right? So potassium, it wants to give this 1 electron away to obey the octet rule, because if that is being given away, you'll be left with about 8 in the next shell. So right here now, it will obey the octet rule. Then for oxygen, it's element 8. If we look right here, if we can draw the shell oxygen also, as we have done with potassium. Potassium, we say for oxygen right here that is oxygen. We can write the first shell of oxygen right here, and we say that the first shell takes 2 electrons. Let me place that back there before we forget. So you can be seeing that. So we say 2, 8, 8, 18, 18, 32, 32K, or 118 as total element on the provided table. So if we have done that now. This is oxygen. So the first shell of oxygen, it takes 2 based on this. So it takes 2. Say we go 1, 2. Oxygen is element 8. We have consumed 2 electrons. How much less to make it 8? Pendant 6 more. So we draw our next shell right here. The next shell. So the next shell, it takes the maximum of 8. And we have got zone 2 here. Pendant 6 to make it 8. So we can put the 6. We can put a 6 right here. We can say 1, 2, 3, 4. Remember, we do that single before we try to double them. Alright? So we have 1, 2, 3, 4, 5, 6. 2 more to make it 8. We can double them by saying 1, 2. So we can now say 1, 2, 3, 4, 5, 6, 7, and 8. So in this case here, now the last share of oxygen right here, it has 1, 2, 3, 4, 5, 6. It has 6 electrons in the last share of oxygen. That's why it has been placed in group 6 because of its last share. So the last share has 6 electrons there. 1, 2, 3, 4, 5, 6. That's why it's being placed in group 6 right here. For potassium, the last share has only 1 electron. That's why it's being placed in group 1. Hope you have the logic right there. Right? So it means that for this one right here, for oxygen, it forms 2 bonds. Here is vacant, here is vacant. It forms 2 bonds. But if you look right here, it's a lone pair. Here, bonding does not take place right there. You don't bond there. Only those single ones that need to be connected. So oxygen forms 2 bonds because the last shell right here, it can accept 2 more electrons to make it 8. So oxygen here, it prefer to obey the octet rule than to obey the duplex rule. Why? Because here it has 6 electrons in this shell right here. It prefer to gain 2 to make it 8 than to lose the particular 6 all here to obey the duplex rule here. As you can see right here, if oxygen lose all those 6 here, then it will obey the duplex rule. 2 will be left right here. Oxygen said no. To lose 6 and to gain 2, which one is much easier? Oxygen say, I prefer to gain 2 than to lose whole 6. Right? So to lose 6 is difficult, to gain 2 is easier. The same thing with potassium. Potassium say that I prefer to give away this 1 year than to accept 7 or delay. If I give away the 1 year, I will still obey the duplex rule. If I gain 7 more, I'll still obey the duplex. Excuse me, rather. If I get away this 1 electron, I will obey the octet rule because 8 will be left right here. And if I give my 7 more to make it 8, I'll still obey the octet rule. So oxygen say that, potassium say that no. Let me just give away the 1 year to obey the octet rule in simple form. Hope you understand how bonding work. Right? So this guy you see right here, oxygen, it wants to form 2 bonds. Because it left with 1 year vacant and 1 year vacant. When this guy wants to give away what? Only 1 electron. So if this guy you see right here, if he gives away this 1 electron right here, all we accept it. Because we say ionic bond is the transfer of electrons between metals and non-metals. So this is a metal and this is a non-metal. So this guy here lose this 1 bond right here, this 1 bond to this guy right here. Oxygen grab it. So if oxygen grab that now, then here now it become what? It become a lone pair right here now. So it'll be 1, 2, 3, 4, 5, 6, and 7. Because it already accept this. So it becomes 7 right there. Understood that? It accept this, it becomes what? 7. Then 1 more left here now to make it 8. To bond it to make it 8. Because we say we have 1, 2, 3, 4, 5, 6. If this guy lose this 1 right here, it give it to or accept it because 7. 1 left right here. It means that to bond potassium and oxygen, you need 2 of what? Potassium to what? 1 oxygen. So we can write the same diagram as repeated. We can write K right here. We can write K right down here. We can write K. To the first share of K. We say the first share of K, it takes 2. We're just repeating the same thing. It takes 2. The next one there, it takes 8. 1, 2, 3, 4, 5, 6, 7, 8. So 2 plus 8 give us 10. Pana how many more to make it 19? Is pana 9 more, right? So the next year, we said the next year it takes 8 also. So like I said, we just draw the scene diagram right here. So we draw the scene diagram. So the next year it takes 8. 1, 2, 3, 4, 5, 6, 7, 8. Right? So the next year now, the next year here, how many it takes? The next year, how many it takes is 1 right here. So we can draw that scene here. So the next year that you see here, it takes 1. So if you check, oh, it becomes 19. So it means that potassium also wants to get away 1 electron, so it gives this one to O accept. Then O become 8 right here. O become 8. So the total will be now 1, 2, 3, 4, 5, 6. Say accept this, it become 7. It comes to this. It accept this, it become 8. So O now obey the octet rule. Wherein for potassium, once it get away the 1 here, then 8 will be left in the other shell. So both potassium and oxygen obey the octet rule. So it's very, very easy to understand ionic bonding. So it was had this equation that says if you add K plus O 2 minus, what will you produce? In the same scenario right here that we just show. Right? So it means that this gives this one to O accept, because it's a transfer electron. So the K gave this positive to O accept it, and this 2 here you see here, it gave it to what? To K accept it. So it become many K now. Where K, when it is superscript, when you accept it as an electron, it becomes a subscript. So it becomes 2. The 2 will come down, and then this O here. Say this O was minus 2 and give it to K. So K now gives the positive to O. So just have 1 O right here. So it is, you see it? So the same thing with this 2. How many K here? It's 1, 2. So it's 2. How many O here? It's 1. So it's the same thing as this or this. Hope you understand this and learn chemistry to be able to understand more things about bonding and how things work, right? So we can now move to covalent bond. What is covalent bond? We can say that covalent bond is the sharing of electrons between non-metals. Covalent bond is the sharing of electrons between non-metals element. So we can give scenario about that. Let me erase this from here. We can give scenario about that. We can say covalent bonds. Again, we say covalent bonds are the sharing of electrons between non-metals elements. So if you look here to non-metal element, I would say for instance you want to bond fluorine to that of fluorine. You want to bond fluorine to fluorine. That is, you have 2 fluorine, right? Or I would say don't use like hydrogen. Hydrogen is a non-metal, though it's being placed in group 1. So we say if you have to react hydrogen ion plus, let's say, plus water, which is H2O, the COO2 minus. We say for this is a non-metal, even though it's in group 1, for it's a non-metal only for H, then for O is non-metal, so this becomes an ionic equation, right? Excuse me, this becomes a covalent stuff we are about to form right here. Covalent because it exists between non-metal elements. So in this case here, we are not going to transfer electrons as we did in the previous one, but logically we will transfer. logically, by seeing, we will transfer. But if you analyze, you will say no, it wasn't transfer. How? If you have to say, you take this two from this one from here, you give it to oxygen, it accept it becomes just O. Then there's 2 here, it comes here, it accept it, it becomes just H2. The reason is you have positive charge here and negative charge. So they will attract, they will come together, they form bond, they will attract. But if you have like fluorine ion reacting with another fluorine ion, they say, what would this produce? This is a non-metal and this is non-metal. The same element, negative charge and negative charge here, where the same charge. For here, it's kind of different, so they will attract. For this, they won't. So it means that fluorine wants to accept 1 electron. This guy wants to accept 1, 2. To write that now, you will have something we call F2. F2 where you have 1 fluorine here and 1 fluorine here. You know what? F2. Difluoro. So in this case of this right here, it looks that we are transferring. By just seeing this, we are transferring. But logically, we are not transferring. But because of the charges right here, we transfer. But in the diagram form, we are not transferring. We share the electrons. Okay. So this now happens, it becomes H2O. It becomes water because this 2 came to this H and this 1 here go to O. Okay. So we can also try to give a structure. The structural form of this, how it's being portrayed. How can we understand that fully? So to do this now, we can say we have H here is positive. We draw, let's take the charge from there. We draw H here. What is the atomic number of hydrogen? So what is the atomic number of hydrogen? Well, the atomic number of hydrogen is 1 because hydrogen is the first element on the periodic table and it has the proton of 1. It has 1 proton. It has 1 proton, and mostly hydrogen it refers to as a proton donor. But in our next video on assay and basis, we are going to show that. Okay, so hydrogen is 1, is element 1, so it has 1 electron. Then what becomes of oxygen, we say is element 8, right? So we draw, get rid O as oxygen. In the first shell here, we say it takes 2. So we can write a 2 right here. We write 1, 2. And the next shell takes 8. But we have consumed 2 in this first shell. We are level bound at 6. So we draw the next shell and we can place the 6 electrons into them. 1, 2, 3, 4. Try to double. 5, 6. So it has 6 electrons in the outer shell or the valence shell. So it's how this element oxygen is being placed in group 6 because it has 6 electrons in the outer shell. And it has 1 electron in the outer shell. So it tells that this element is being placed in group 1. It's very, very, very simple. Chemistry is just simple as it is. Okay. So here now we say it is covalent compound. They don't transfer electron. Though we saw it here being transferred, but logically they are sharing their electron. How? This guy right here, this guy here, if H gives away this 1 here, which rule it will be? Will it be duplex rule or let's say octet rule? If H only has 1 electrons, if H gives away this 1 here, this 1 electron you see right here, will obey the octet rules or the duplex rule? It will obey any rule. You give away 1 level, nothing, right? Okay, so the Asian prefer to share with somebody in order to obey one of the rules, be it duplex or the octet rule. So we can try to figure out that which rule does H obey. All right. So if you look here for oxygen right here, this guy wants to accept 2. in order to obey the octet rule. As you can see, if it accepts 2, it becomes 8 in this last shell. And if it gives away this whole 6 you see here, then you'll be level 2 in the next shell. But once you give away the 6 here, if the shell get broken, the next shell leave right here. But it said no. I prefer to gain 2 than to lose 6. To gain 2 is easier than to lose 6. So oxygen wants to obey the octet rule, right? So in this case here now, you have this to this in the structure right here. This guy wants to accept 2 to make it 8. And this guy here want to do what? You want to give away 1 electron because it's in group 1. So group 1 element they want to do what? They want to lose 1 electron mostly. Okay. So if this guy here now take this 1 and get into this guy here, it becomes what? It becomes 7, right? It becomes 7 right here. But it said no. If I get away the 1 here, I will left with nothing. So it better we share. If you get 1, I get 1, we can share it. Then we get 2. 2 or have 2. So the H here, can you see right here, H prefer to share